All right, so this is start of section 6.3. Now we're going to cut this into 2 days. So we have section 6.3a and then we'll have a section 6.3b. And we're really going to get a jump into logarithms, or we call them logs for short. Okay, this is probably going to be something completely 100% new to you that you may have never even heard of. So just know that if you're uncomfortable at first, that's normal. Okay, we're going to do a lot of reps and they'll get more comfortable to where most of you should find them pretty easy when we're all said and done with them. All right, so just to review a few things about inverses. Okay, so it says a function and its inverse are sketched in the same coordinate plane. How are the graphs related? Okay, so I can say the graph of f of x and f negative 1 of x, or the inverse of f of x, are reflections of each other over the line y equals x. All right, so if I have a coordinate plane, here's my coordinate plane. The line y equals x is right here. Okay, so a function and its inverse are reflections over this line here. Okay, how do the domain and range of f of x relate to the domain and range of f prime x? So I could say the domain of f of x is the range of the inverse of f of x, and then the range of f of x is the domain of the inverse of f of x. Okay, so the domain of one is the range of the other. The range of one is the domain of other. We flip the domain and range between the two. All right, we are going to start with logarithms. Okay, know that the reason we like logarithms is because they relate to exponentials. Okay, now we will eventually come to find that a logarithm and an exponential function are inverses, and so we can actually solve one with the other. Okay, so that's why logs are important. Okay, know that this here is the same thing as this here, just written differently. These are equivalents, okay? So the b and the b, the y and the y, and the x are all the same in these two things. Okay, so I'm going to go ahead and here's my b. Here's my x, and then here's my y. All right, let's do an example here. First of all, kind of going backwards, this here, log b of y equals x, I would say this log base b of y equals x. Okay, so that's how I'd say it. Log base b of y equals x. Okay, so this is the same as b to the x equals y. Okay, so think, for example, 3 squared equals 9. Okay, if I wanted to write this as a log, okay, so my b goes here. So it'd be log, now my b, guys, is the 3, so my bases are the same. Next I have my y, and my y over here is what the exponential function is equal to, so that would be 9 equals, my exponent is the x, so my exponent is 2. Okay, these two are equivalent, just written differently. All right, let's look at example 1. I'm going to write each of these logs into exponential form. Okay, so remember, b to the x equals y can be written in logarithm form as log base b y equals x. Okay, so my b is my base. Okay, so my base here is 2. My exponent is my x. So my x here is 4 equals my y is my y. So it equals 16. Okay, that's it. So here my base is 4. My exponent is 0. What it equals is right here. So 4 to the 0 equals 1. Okay. Let's look at C. Okay, so my base is the same. My exponent is what it equals. And then what it equals is right there. All right, one more. Let's look at D. Okay, so 1/4 is my base. My exponent is over here. What that equals is right here. Okay, it's that easy. All right, let's do it the other way now. Okay, so we want to write these in logarithmic form. So I would say log base, we always have the same base, log base 5 of 25 is equal to the exponent. Okay, let's look at this one. So it's log base, we have the same base, log base 10 of what it equals, 0.1 is equal to the exponent, which is -1. Okay, I want you to pause this, try to do C and D on your own, look at the pattern we did here, and then we'll go over it. All right, hopefully you did these on your own. So C should be log base 8 of 4 equals 2/3, and D should be log base 6 of 1/216 equals -3. All right, guys, these two you should get to the point where you could recognize pretty easily. Okay, so log B1 equals 0 always, because if I rewrite this as an exponent, it'd be B to the exponent of 0 equals 1, which is a true statement. Okay, so anytime you see log base B of 1, just know that it's 0. Over here, log base B of B equals 1, because if I rewrite this as an exponent, B is my base to the first power is going to be B. So these two should make pretty easy sense to you. All right, so here we're going to evaluate each logarithm. Okay, so most of us are more comfortable with exponents, myself included. So I first like to write this out in exponential form. So I'm just going to say equals x because I don't know. I'm going to call it x and then solve for it. Okay, so if I write this as an exponential function, I would write 4 to the x equals 64. Okay, well, guys, 4 to the first is 4. 4 squared is 16. 4 to the third is 64. Okay, so my x then has to equal 3. So my answer to this is 3. All right, let's look at B now. Okay, so I could say 5 to the x equals 0.2. Okay, now guys, when you're dealing with decimals, it's a little harder to see. So I'm going to change this decimal to a fraction. So 5 to the x equals 0.2 is 1/5. Well, we all should know that 5 to the -1 is equal to 1/5. So therefore my x is going to equal -1. So the answer here is -1. All right, let's look at C. Okay, if I rewrite this as an exponential function, I would have 1/5 to the power of 5 equals 125. Okay, now I immediately can see that whatever this is, it's going to be a negative exponent because I want my denominator to come up to the numerator. So just kind of make a note to myself. Well, guys, 25 is 5 to the third. So 1/5 to the x equals 5 to the third. Okay, so wouldn't 1/5 to the -3 equal 5 to the 3? Right? So x then has to be -3, so my answer to this would be -3. All right, last one, let's look at D. If I write this as an exponential function, 36 to the x power equals 6. Well, guys, square root of 36 equals 6, and square root of 36 is just 6 to the -2 power. So, 36 to the -2 power. So my answer here would be -2, and that's it. All right, so two of the most used logs are the common log and the natural log. Okay, so the common log is basically just log base 10. And since it's one of the common logs, anytime there's no number, we know it's assumed, or maybe I should say accepted, as base 10. Okay, and here we would actually log base E, this is actually ln is natural log. I don't know how they get ln from natural log. I have no idea. But it's natural log, so log base E will generally be turned into natural log. Okay, so if you see natural log, you can think of this as just log base E. Same thing. All right, let's look at example 4. It says evaluate using a calculator. Okay, so the log button on your calculator, okay, here's your screen. If you're on a TI-82 or 83, it's on the left. Mine's like 4 up. This is my log button. Okay, so I want you to go ahead and find that. And then my natural log, my natural log is the number below it, and it just says ln. So depending on what calculator, it may be a little bit different place, but in the TI-83 and 84s, its log is on top of the natural log, and it's on the left-hand column on the bottom. Okay, so to put this in your calculator, seriously, all you do is hit the log button, put 8, and then equals, and you should get roughly 903. Okay, remember this is log base 10, right? Because the 10's not written, so it's understood. So basically what this is saying is 10 to the 903 power is roughly 8. You can check that in your calculator, and you should get, remember that's approximated, so this will be approximated too. Okay, same thing, natural log, all you have to do is hit ln and then 0.3 equals in your calculator, and you should get roughly -1.204. Okay, and remember this is log base E, right? So this is the same thing as log base E of 0.3. Okay, so what this answer means is that if we put into our calculator log base E, e to the -1.204, we would get roughly 0.3. So if you don't believe me, go ahead and try it. All right, guys, because this is so new, I highly recommend you do these monitoring progress. So I highly recommend you pause this now, work these through, and then come back and check your answers. And if you made a mistake, kind of look to see where that mistake was made. All right, so this is what you should have gotten. Okay, so here's the top part. And then if I scroll down, here's the bottom part. These two you should have done with a calculator. This one you should have done without a calculator.